Welcome to The Explainer. Today, we are not just going to answer a GCSE chemistry question, we are going to crack the code. We're going to look right over the examiner's shoulder and see exactly how marks are really won, and yeah, how they're lost. We're going to use the official AQA mark scheme to basically reverse engineer the perfect answer for a kind of tricky question about salts. Honestly, think of it as your cheat sheet for the exam, right? Let's get into it. Okay, first up, let's dive into question 05 from the AQA higher tier paper. It all starts with something that sounds simple, naming salts. So here it is. The question wants us to name the salt you get from a classic neutralization reaction. You've got potassium hydroxide and hydrochloric acid. So what do you get when they react? And the mark scheme confirms it. The answer is potassium chloride. But wait, here's our first big clue. Look at that extra info, allow KCl. Now that's a direct instruction to the examiner. It means if you're confident with the chemical formula, you can just write that down, save a few seconds, and still get full marks. That's a great little tip to keep in your back pocket. All right, next up, the ionic equation. Now, this is one of those places where being precise is absolutely everything, and the mark scheme shows us exactly what we need to focus on to get that point. So the perfect answer is just the hydrogen ion plus the hydroxide ion making a water molecule. But check out this note. Ignore state symbols. This right here is gold dust. It means you don't have to waste precious time in an exam stressing about adding a Q or L, especially if you're not 100% sure. The mark is for the main event, the core equation, not all the little extras. Okay, now the question totally shifts gears, and we're into practical chemistry. This part tests if you understand lab procedures, and more importantly, why we do things a certain way. So this is a multiple choice question, and really, it's just a test of your basic reactivity knowledge. It's asking which of these solids will actually react with a dilute acid to make a salt. Just take a look. Which one feels like the odd one out? And here's why it's such a good question. The mark scheme confirms the right answer is copper carbonate and copper oxide only. The key thing you have to remember is that copper metal itself is just not reactive enough to kick off with dilute hydrochloric acid. Only the base, which is copper oxide, and the carbonate, copper carbonate, are going to do the job here. Okay, now we have to explain why we do 3 specific steps when making salt crystals. This is a 3-mark question, so that means we need a clear, solid reason for each step to make sure we bag all the points. And here they are, the exact mark-winning phrases straight from the horse's mouth, the mark scheme. For step 2, it's to speed up the reaction. Simple as that. For step 5, it's to make sure all the acid reacts, which is so important for getting a pure salt solution. And for step 6, it's to remove the excess solid. Each of those key phrases locks in 1 mark. This is a classic question about safety and proper lab technique. So you've made your salt solution, but you can't just blast it with a Bunsen burner, right? So what is the correct way to gently heat that filtrate to get those nice crystals to form? And the mark scheme gives us 2 perfectly good answers. You could say using a water bath or using an electric heater. Both of these give you that gentle, controllable heat that's so important for growing good quality crystals and, being safe in the lab. You only need to give one of them to get the mark. And now for the big one, the calculation. This is often where students get a bit nervous and drop marks. But if we just follow the structure in the mark scheme, we can see exactly how to secure every single point. So here's the mission. We need to figure out the volume of chlorine needed to react with exactly 14 grams of iron. We've got the balanced equation, the relative atomic mass of iron, and the molar volume of a gas. Basically, we have all the pieces of the puzzle. Let's see how the 3 marks are actually given out. So the mark scheme gives marks for these 3 separate steps. Following this structure is so important because it means you can still get error carry forward marks. What's that? Well, it means if you mess up the first step but use your wrong answer correctly in the next steps, you can still get marks for your method. That is a total game changer. It's like a safety net. Okay, first things first, let's calculate the moles of iron. It's just mass divided by relative atomic mass. So that's 14 divided by 56, which gives us 0.25 moles. Write that down, show you're working, boom. That's the first mark in the bag. Next, we look at the ratio from the balanced equation. It's 2Fe to 3Cl2, right? So the ratio of iron to chlorine is 2 to 3. To find the moles of chlorine, we just multiply our moles of iron by 3/2. That's 0.25 times 1.5, which gives us 0.375 moles of chlorine. And just like that, that's your second mark. And finally, to get the volume, we multiply the moles of chlorine by the molar volume, which the question kindly tells us is 24 decimeters cubed. So, 0.375 times 24 gives our final answer of 9.0 decimeters cubed. And that's it, the third and final mark. Job done.
So, after all that, what have we actually learned from just digging into this one question? What are the key strategies we can pull from this that you can use in your own revision?
Look, the big takeaway here is that the mark scheme isn't some secret document. It's your roadmap to getting the grade you want. It tells you exactly what to focus on, learn the reasons for practical steps, show every stage of your calculations, and pay really close attention to those golden words like allow and ignore. They are literally clues from the examiner on how to score points. Honestly, this technique of analyzing a mark scheme is a revision superpower. It takes you from just knowing stuff to knowing how to score the marks. So the real question is, what tricky topic are you going to decide to master next using this exact same method?